Hi everyone, welcome to the new video. Uh, I'm in a new place again. I'm just changing places now. So in this video, I'm covering another CV, following up from the deserialization bug that we covered last week. This week, I'm doing another injection vulnerability that is the infamous SQL injection. This the same package that is Apache Log4j 1.2.17 is also vulnerable to an SQL injection. Funny thing, right? A package vulnerable to multiple vulnerabilities. Uh, but in this thing, it's on the SQL side, and my aim is to actually walk you through what all is happening here, the code, and things like that. So let's get started. First things first, I have the package right here, that is Apache Log4j 1.2.17. I have basically untarted. All files are here. But in order to go through the code better, I thought like, hey, maybe I'll open it in VS Code. Uh, so I guess I don't need to focus that much. I think this is viewable now. Um, okay, what is essentially this vulnerability? Um, So for the viewers who don't know what SQLi or SQL injection is, at a very basic level, think of SQL injection as an attack where you as an attacker can insert malicious SQL code into the actual SQL statement. That is what SQL injection does. Say if you're inserting value A into a table, what SQL injection allows you to do is that you will be you can append some things after, like, on the statement, so that maybe you can drop the table, or you know dump the entire information from the table, and things like that. So things that it is not supposed to do. In this in this Apache Log4j project, they use JDBC or SQL services for storing or logging all of the logged information into a database. So in large organizations, maybe you would want to log your information into a database instead of a log.txt file. People do that. Maybe like for logging information, say if you're logging into a website, these things can be put into a database per se, and kept track of. That is the reason why mainly a JDBC or a database is preferred in these type of logs. Now we got out the high level overview. Let's dig deep into what's actually the problem. The SQL injection SQL injection actually present in this package is was actually known to the developer, which is a funny thing. Like the developer actually commented it out saying, hey, don't use quotes in your logs, otherwise there can be a scenario for SQL injection. I will get into that very soon. Start really looking at what is the bug. Okay, how Log4j takes in the logs is using the JDBC appender. So that is how there is a file called JDBC appender uh, in their main folder Java or Apache Log4j. Inside that there is a JDBC folder where you have all the instructions for connecting to the drivers, executing things, how to log errors and things like that. So in this code, the particular issue is that, so you can see here they are using JDBC appender. They have an appender skeleton outside which actually has further details of the file, like the database user, URL, things like that. But if you go down here, this is actually one of the issue. They're just taking the user input or the logs in the sense directly and passing it into this SQL statement. They're just putting it out. This is what I was saying. Like the developer actually mentioned here that, hey, be careful of quotes in your messages. And w- in the above section as well, you can see stores the string given in a pattern layout for conversion in an SQL statement. Okay, now we need to go back a bit. So we found in the JDBC file where the statement is getting stored. But if you move back a bit, you will be wondering, okay, how is the log getting parsed and how is it getting, say, if I'm sending a log that user A logged into a website with IP address X, uh, how is it taking that string and putting it here? So then you need to move back to another file that is outside of this folder called pattern layout. So pattern layout is a code that they use for, finding patterns in the code and setting it up and sending it to uh, the SQL statements, or in maybe even in the socket node that we have seen. So wherever areas that a certain form of pattern is needed, this will do the parsing. And this is all like really well documented here. So but if you go down to the actual section, so there's a lot of things that is happening here. We go down. Yeah, okay. So now this is the core thing that is happening here. So we have a pattern layout which extends another class called layout. So by default the pattern string is looking for a log output, and it is getting stored in this pattern, that is percentage %m is the log, and it's doing a new line after that. So any log that comes in, it will be here and a new line will be there. So that is how things look like, so that each log will be in a new line. This is a really cool thing as well. Like they have multiple patterns. So you have a default pattern where you're just having the message followed by a new line. Then there is something called TTCC layout. What it means is that you have the time, you have the thread, you have the context, you have the content, and you have the class. Uh, or maybe the class and the content after that. So that is how what it means. So let's say let's take the case of the socket node that we did, right, where hundreds of threads might pop up when people are connecting. What if we are logging all of that? So we need to know the time, we need to know each thread, each of the thread produced, then we need to know the context. We can also know which classes were invoked, and finally what was the content in the actual message as well. So that is also a cool thing that is here. Now the problem where the SQL injection actually happens is that they are not actually doing any sanitization check on the input. So whatever log is coming in, it's directly put into the SQL statement. So you say, let's take Varun logged in at X time with IP address X, user used all of these information, it will just directly be here. And um, and what let's take a simple example here. Maybe Varun logged in at 10:30 p.m. uh, using IP, maybe some IP address, using some IP address or something like that. It will directly be put in over here in the message field. So that is kind of the problem that is here. It's not getting sanitized. And as you see in the SQL statement, this is a JDBC appender file. So if you go down, um, you can see how they are executing See, they're executing it by directly passing in the SQL string that we found and statement.execute update. So s- whatever the log input is coming is directly passed into the passed into the SQL statement. So that is the problem that you see here. So that is the vulnerability. Now let's see how let's like quickly do a POC on um, POC to understand the bug. Increase the size. I'll go back a directory. So I created a folder called SQLi and I created an application logger dot java. Just set some numbers so that we can see numbers. So I imported the logger, then some property configurator because we are using the configuration file. So I forgot to tell you one thing. So uh, you might have a question, how are the actual logs even coming in? So in these Log4j actually uses something called config property files. We have used that in the previous socket node example as well. So so this is the one defining how much log information you need and how, and it is kind of getting all of the, it acts as a getter as well. It's actually getting the logs and sending it. So if you see, it's I'm saying, hey, I need info level logs and I'll be using JDBC. I have given debug as true as well so that I can see the issues that are coming up or see the logs. I'm using the JDBC appender class, as you can see here. I'm specifying which log DB to use. I'm using the SQLite JDBC driver, which you will see in a few moments. And see that this is what's happening. Like I'm just directly putting in a insert into the log table these much messages of value, whatever the log message is. And I am using the pattern layout as well. And conversion pattern is using, I'm just using the message as it is. So this is how machines will be configured which are using log4js. Okay, now let's look at the application logger.java file, setting numbers. So just configuring, I'm just taking the configure.properties file, setting, hey, we're going to use this application logger class. Um, String, so the logging here is basically it's made up thing where a user is logging in from an IP address. So in an actual scenario, you will be actually sending the information across to this logger, not essentially entering it in. So here, for the sake of it, I'm just putting in like, hey, logger info, username and IP address, and it will directly get passed. And I'm printing it as well so that you can see how it looks. Just checking to see if both arguments are there or not, like the username and IP address. So I think I have shown you the config properties and application logger. Next thing to do is that actually create a logs DB. So you can, I'm using SQLite 3. You can create a DB by using SQLite space the DB name that you want .db. So I'm using that. You can see database, which has read write and everything in, and you can see .t to see dot table. Yeah, you can see the table as well here. So I do have the create table instruction that I did. Okay, there was a lot of, yeah. So I'm just this is basically it. Creating a table, log table, message text. That's basically what it's there. Uh, okay, so I exited it. In order for this to work, actually, you need the SQLite JDBC as well, so that it the Java program needs to communicate to SQLite, right? So all of the classes that is needed for that is in this SQLite JDBC. You can, I guess, download it. You can just search it out and was it? somewhere over here. Yeah, this one. So you can download a jar from this website, Maven repository, and that's it. Now let's compile it. So I have everything here. That is kind of the bug that I want to showcase, but uh, history tail minus and maybe 20 of it. Okay, so here you can see I'm just using it to compile the program. I'll just do the same here. As you can see, I'm compiling the program using the log4j jar and the SQLite jar as well. Once I compiled it, I can run the program using Java CP, and let's instead of doing the SQL injection first, uh, maybe let's just try to enter in an actual value. So this make it a bit more unique. Let's make it a new user 10.10.10.10. Uh, let's we missed a Java in front. So now if I go to SQLite 3 logs db and select star from log database, I guess log table, that is the one. So you can see a user logged in from IP, that information is getting logged. These are all prior information that I have put in to the DB. So now you have seen actual. So this is how the real logging works. But what if you are sending in maybe something like, where is it? Where is it? Where is it? Going back, going back. Yeah. This is an example of an SQL injection. So it's logging the first parameter Varun. Second parameter is the IP address. Now see, I'm closing the SQL statement using a colon, escaping all of that. And I'm inserting. I'm not dropping the table per se because again I have to create the table and stuff. But I just want to show you, hey, SQL injection is done. I guess if I just do that, right? Um, okay, the reason why I was not able to see that, I'll do it better. Okay, SQL injection is uh, yeah. Now you will have actually two entries now here. Let's just check out the logs DB. Select star from log table, right? Log table, right? See, you have the last one as well, and the one before that, the actual message. So that basically proves that you can do SQL injection. And to do even more of a damage, you can do something like, uh, you know, drop table, log table, right? Drop table, log table. Yeah, that should work. And if I just do it, and if I just do SQLite 3 logs db and do dot table, see, no table is there. Like select star from log table. See, no log table. So this is the really bad impact that SQL injection can cause. And this is the JDBC vulnerability that is there. Thank you all so much for watching. Um, so see you in the next one. Take care.